Problem 8. Let f of x equal to x squared times 1 minus x squared. What is the value of the sum of the given expression? So when you have a series where there's a very evident pattern, chances are the numerical quantity at the very end will be very simple, like 0 or 1. Notice as well, we have alternating plus and minus signs. And notice again, where the first term and the last term differ in sign. The same goes for the second term and the second to last term. So there might be a potential sequence where everything eliminates with each other to get a very simple answer. To test our logic, let's try simplifying each quantity. F of 1 over 2019 becomes 1 over 2019 squared times 2018 over 2019 squared. But then the negative f of 2018 over 2019 becomes f, or rather not f, it would become 1 or 2018 over 2019 squared times 1 over 2019 squared. But notice here that they differ in sign. So this quantity would eliminate with the very last quantity. So this should give you a very immediate suspicion. And you might be wondering, hey, how did I know to look at the first and the last term and then look on from there? Well, the reason for this is because when you have alternating signs, chances are things cancel. So this typically occurs with opposite quantities or conjugates in fractions. So the same goes for 2 over 2019, right? This becomes negative of 2 over 2019 squared times 2017 over 2019 squared. But then this quantity, the second to last quantity, becomes plus 2017 over 2019 squared times 2 over 2019 squared. Notice that they're conjugates of each other, so therefore this and this would eliminate, this and this would eliminate. So we know from this deductive reasoning that every outer term would cancel with, the most beginning term correspondingly. So the first would cancel with the last, second to last would cancel with the second, third to last would cancel with the third. But how do we know where to stop? Well, if I were to have 2018 terms, because the numerator goes from 1 all the way to 2018, what are the middle two numbers? Or do I even have a middle two numbers? Well, give yourself a simple test case. If I have 4 terms, right, do I have a middle two numbers? Well, let's say I have 1, 2, 3, 4. The answer is yes. Obviously, the middle two numbers exist. But what about 5 terms, right? If I have 5 terms, that's 1, 2, 3, 4, 5. So if I have 1, 2, 3, 4, 5, then that would mean that I do not have a middle two numbers to cancel. I only have one median. But since this is an even number of terms, like 2018, that means it's guaranteed that there are 2 middle numbers that cancel with each other in the very end. So ultimately, we get 0 with nothing left.